Hello everyone and welcome to Chem Talk, where today we will be discussing measurements, SI units, and scientific notation. So let's talk about it. In order to talk about measurements, first we have to understand what a quantity is. A quantity is information that demonstrates the behavior of matter, and it is broken up into three parts. First, the size of the measurement, which we will call the magnitude. Then there is a comparison standard, which we will call the units. Then the variability of the measurement, which we call the uncertainty. This will be our main topic for our next video, but for now we are only going to focus on the measurement and the unit. Now take this can of soup that weighs 328 kilograms. This can be written in two ways, the first being decimal form. As you can see, we have the size of the measurement or the magnitude, which is 328, and then we have the comparison standard, which is the kilogram, and this is also our unit. A comparison standard is just a universally agreed upon thing that we compare something to. A kilogram actually came from a solid cylinder of platinum, and is what we compare most other objects to. So this can of soup's mass is equal to 328 cylinders of platinum. The second way we can write this is in scientific notation. In scientific notation, there's only one value before the decimal point. If the number has more than one, the decimal is moved and a 10 is added to represent the amount of times the decimal needs to be moved. When the decimal is moved to the right, you add a negative exponent, and when it is moved to the left, you add a positive exponent. Now, let's practice this. Let's say your cat is overweight. In order to get him the correct food, the vet asks you to write down his weight. You know that he is 58.89 kilograms. Express this in decimal and scientific notation form. Go ahead and pause the video, attempt the problem, then we'll get to solving it. So first, in decimal form, we write it as 58.89 kilograms. Now, in scientific form, we need to move the decimal to the left, which means you add a positive 1 exponent to your 10. Now, you might be wondering why we're using kilograms and not grams. Well, that's because it is a standard unit. In the US, we usually measure things in pounds for weight, inches for distance, and Fahrenheit for temperature. Well, this isn't the standard, and when measuring scientifically, we use what are called SI units, which is actually an updated version of the metric system. These values are agreed upon internationally and are what is used in material safety data sheets and other reported data. The SI units all have a property, a symbol, and a unit length. For the length, we use the symbol m for meter. For mass, we use the symbol kg for kilogram. For time, we use s for seconds. Temperature is an uppercase K for Kelvin, and for an amount of substance, we use mol for moles. Now, quiz time. If I was measuring the length of a tube, what units would you use? Yes, you would use a meter. But what if a meter was too big? Even though we have a base unit in the SI units, it isn't all-encompassing, and this is where prefixes come in. Prefixes are fractions or multiples of a base unit. For example, 2 grams is equal to 0.002 kilograms. This is because when the value is 10 to the 3 times bigger than the base unit gram, we have agreed to call it a kilogram, with kilo being the prefix. Now each prefix has a symbol and a factor. Kilo is K and is a factor of 10 to the third. Hecto is H and is a factor of 10 to the second. Deca is a capitalized D with a factor of 10. Deci is D with a factor of 10 to the negative 1. Centi is C with a factor of 10 to the negative second. Milli is M with a factor of 10 to the negative third. And micro is the Greek letter mu and is 10 to the negative sixth. Now, some of these may be recognizable, like centi and milli. The prefix is just added to the base unit that is being measured, like centimeter and millimeter. It is just saying that a centimeter is 10 to the second times smaller than a meter. Now, this is a lot to remember, but a good way to memorize it is by saying King Henry died by drinking chocolate milk. Each letter represents a prefix, and the B represents the base unit. When trying to convert between prefixes, you can draw this phrase and use the letters to count the decimal places. If I need to convert a gram to hectograms, I look at the letters. I have to move twice to the left in order to get to hecto, so you would just move the decimal to the left twice to get from grams to hectograms. Now, let's try some practice. You are an architect finding the area of your floor plans. The length of the room is 10 meters, while the width of the room is 25 meters. Express the area in kilometers. Pause the video and try it yourself, and then we'll get to solving it. Now we know the area of a square is length times width. Our length is 10 meters and our width is 25 meters, so when we do 10 meters times 25 meters, we get 250 meters squared for our area. Now the problem asks for the answer in kilometers. So King Henry died by drinking chocolate milk. To get from meters to kilometers, we move the decimal 3 times to the left. So we get 0.250 kilometers. Now there's a second way we can do this, by converting first. So still our length is 10 meters and our width is 25 meters, but if we move the decimal 3 times to the left, we get 0.010 kilometers and 0.025 kilometers, and you end up at the same answer, 0.250 kilometers squared. Kilometers squared would then be the unit that is describing the area. This brings me to derived SI units. SI units can be used to create other units to describe properties. Volume, for example, is the space occupied by an object. If we have a cube with a length of 1 meter, the volume of the cube is going to be 1 meter cubed. The standard unit for volume is any meter cubed and represents the amount of stuff we can fit into the cube. It is also important to know that a decimeter cubed is a liter and a centimeter cubed is a milliliter. Now, density, as we know, is the ratio of mass compared to its volume. If we have a cube with the volume of 1 centimeter cubed that has a mass of 3 kilograms and another with the same volume of 1 centimeter cubed and a mass of 20 kilograms, we know that the second is more dense because it has more mass per volume. Density is represented by the Greek letter rho, and it is the mass divided by the volume. Using SI units, we know that the units will be in kilograms per centimeter cubed. Now, let's put it into practice. You have a block of gold with a length of 4 millimeters, a height of 3.5 millimeters, width of 7 millimeters, and a weight of 26 grams. Calculate the density and report in SI units and scientific notation. Now we have the cube with 7 millimeters, 4 millimeters, and 3.5 millimeters, and we know that the volume of a cube is equal to the length times the width times the height. So our volume is going to be 7 millimeters times 4 millimeters times 3.5 millimeters. That means that our volume is going to be 98 millimeters cubed. Now we know that density is rho, and it is equal to the mass over the volume. Now our mass is 26 grams, but we want to convert this to kilograms. So again, by using King Henry died by drinking chocolate milk, we know that we need to move the decimal to the left 3 times. So we get 0.026 kilograms. Now when we do the same thing to the volume, we get 9.8 centimeters cubed. Now we do the mass divided by the volume. 0.026 kilograms divided by 9.8 centimeters cubed, and we get 0.0026536 kilograms per centimeter cubed. Now we can go ahead and put this in scientific notation, move the decimal so there's only one value in front of it, and we get 2.7 times 10 to the negative third kilograms per centimeters cubed when rounded. Now let's just review what we learned today. In summary, we learned that a quantity is broken up into 3 parts. We also learned a quantity can be expressed in scientific notation or decimal form. We also know when measuring scientifically, it is standard to use SI units, and that we can use unit prefixes to describe SI units can also lead to other derived units to describe other properties. So that's all for today on measurements. Thank you for tuning in to Chem Talk. Make sure and go to www.chemistrytalk.org for hundreds of general, organic, and biochemistry videos.